we are going to be doing linear and nonlinear systems of equations. Um, Give me 1 second. Yes, please.
No problem, Mr. Carizales. I hope you all are having a wonderful Friday. Just a quick note that in the chat for the Math 1324, we will be posting a link so that you may get to your session, as well as I'll be sending a private message for your student ID numbers so that you can get credit for coming today. I see, Ms. Chuka, you have your mic on. You ready to go?
Yes, I can start. Yes.
Okay, thank you, ma'am.
All right, cool. So welcome everybody. We will be for Math 1314. We're going to be discussing linear and nonlinear systems of equation. So let's get started. Okay, so first, in chapter 1, we talked a lot about linear equations. And so here we're going to be going back to these linear equations, but we're going to have more than one at the same time. So anytime that you have more than one equation, we call it a system of equations. What we're going to be looking for is a solution to that system. And so a solution is just an ordered pair, and that satisfies both equations when you substitute it into the equation. So if you have this ordered pair and you replace it with x here and with y here, you're going to get a valid equation. And if you do the same for the second one, if it is valid, then we say that it's a solution. Now, sometimes you're going to have more than one solution. And so a solution set is just going to be a set of all ordered pairs that satisfy both of those equations. Okay, so besides having just a linear equation, a system of linear equations, we could also have a nonlinear system of equations. And the difference here is if you have a linear system of equations, that means that all of your equations are going to be lines. But if you have a nonlinear system of equations, that means that you might have, for example, a quadratic equation with a linear equation, or you could have a cubic equation with a quadratic equation. And so it's going to just be different types of equations in there. So we do have different methods in solving these equations. We have the substitution method, elimination, addition method, and we have graphing. From the three methods here, graphing is okay, but it's not the most accurate, especially if you're drawing it by hand on paper. So if you're using a tool like a calculator or a computer, then graphing will be accurate. But if you're taking a test in class and you cannot use your technology devices, then graphing might be not as accurate if you're not graphing it correctly as far as the spacing in your graph and all that stuff. So we're going to focus today on substitution and the elimination addition method. So some books call it elimination, some books call it addition, and then there's other books that call it elimination addition. And so we're just going to go ahead and do this. So what is this solution um, if you have a graph? We're still going to refer to the graph so that we can make sure that we understand what these solutions are. And so on the next page here, we have three different graphs. So the solution for a system is where the two equations intersect. So you might have more than two equations, but in this examples, we have only two equations. And so if we look at the first one, these are both lines. So this is a linear system. And your solution is where the lines intersect. So my solution for this graph is going to be 2, 0. If we look at the second graph, this is an example of a nonlinear system of equations. And the reason is because one of the equations is a parabola. And so in this example, how many equations do we, how many solutions do we have? So again, remember a solution is where the graphs intersect. So how many solutions do we have? We have 2. And so those solutions occur at this point, 2, 1, and 0, -1. Okay, so these are our solutions. And you want to write them as ordered pairs, which we did here. And then over here, this is the third example is also a nonlinear system because of this parabola. And so here we want to find the solution, but if you notice here, the line and the parabola will never intersect. Okay, so there's no solution to this system. So we say that there's no real solution, and we can see that because the graphs do not intersect. Okay. Another name for no solution is going to be inconsistent, and we will talk about that in a little bit. Okay, so how do we know if an ordered pair is a solution to the system? So to check to see if 0, -4 is a solution, in other words, we want to know if that's where the two lines intersect, then the way we checked is we're going to take the equation, and wherever I see my x, I'm going to substitute it with a 0, and then my y, I'm going to substitute with a -4. And if I simplify, then I can see that we get that 4 is equal to 4, which is a true statement. However, we have to check it for both equations. So the second equation, if I do the same, put a 0 for x and -4 for y, then we can see that we get -4 is equal to -9, and that's a false statement. Since one of these was a false statement, then we say that 0, -4 is not a solution to the system. So let's try letter B. So here, if x is a -1/2, y is -5. If we simplify, we get 2 times -1/2 is -1. Negative negative is a +5. And -1 plus 5 is 4 is equal to 4. So that is a true statement. And then the second equation, if I let x equals -1/2 and y equals -5, if we simplify, we get -4 is equal to, or -4 minus 5 equals -9. And so this is also a true statement. Since they're both true statements, we say that, let me go back. Then we can say that the point -1/2 and -5 is a solution to this system. So let's look at our two methods here. And I'm going to work them out next to each other so we can see the difference. So the first one is substitution method. And to do the substitution method, the first thing you want to do is to choose an equation and solve for the variable. So if you look at the first equation, some of you might choose the second equation. It doesn't matter which one you choose. I'm going to go ahead and choose the first one, and I'm going to solve for a variable. And at this point, you can either solve for x or you can solve for y. Okay, so I chose here to solve for x. So I'm going to subtract y on both sides, and I get x is equal to 4 minus y. So now, for step number 2, we're going to take that result that I have here, x equals 4 minus y, and we're going to substitute it into the unused equation from step 1. So if we look at our two equations, we haven't used x minus y equals 2. And so I'm going to write it here, x minus y is equal to 2. Wherever I see an x, I know that x is equal to 4 minus y. So I'm going to replace that with 4 minus y. And then I have minus y is equal to 2. So if we simplify a little bit, then we're going to step 3, solve for the variable. So negative y minus y is a negative 2y. And so this process, what happens is that it helps us to eliminate a variable so that we can solve for the other. And so if I subtract 4 on both sides, then I'm left with negative 2y is equal to 2 minus 4. So I have negative 2y is equal to negative 2. Divide by negative 2 on both sides, so we end up with y is equal to 1. So now we know at least one variable. So to find the second variable, we're going to do something called back substitute. Okay, and so what that means is you're going to take your answer, which is y equals 1, and we're going to plug it into one of the two equations. And at this point, you can choose either one again. So I'm going to choose the first one again. So I have x plus y equals 4, but I already know what y is. Y is equal to 1. So I'm going to have x plus 1 is equal to 4. Subtract the 1. So I get x is equal to 3. So now I know my x and I know my y. So my last thing to do is write it as a solution set or as an ordered pair. So my x is 3 and my y is 1. Okay. So that was the substitution method. And then the elimination method, I'm going to show you that on the right side. And why are we learning multiple methods? Um, Sometimes the way that the system is written will lend itself to one method over another one. However, if you prefer to use substitution all the time, then you can do that as well. Okay. So for the elimination method, we're going to choose a variable to eliminate. And so here, if you don't like y's, then you can get rid of the y's. If you don't like those x's, you can get rid of the x's. So here I'm going to choose to eliminate y. And you'll see why I chose y. Okay. So step 2, once you pick that variable, you want to make sure that the variables, the coefficients have, that the variables have opposite coefficients or that they're opposites of each other. So here I have a positive y and then I have a negative y. So here my coefficient for y is positive 1 and negative 1, which are opposite of each other. And so that's what we want to have. Okay. Once you see that, then we're going to add both equations. So I'm going to have x plus x is 2x, y plus negative y is 0, and 4 plus 2 is 6. So if I solve for x, divide by 2 on both sides, I get x equals 3. So now that you know x, then you're going to go back and find y. So that's going to be your fourth step, is to back substitute. Again, you can pick any equation. So we're going to have x plus y is equal to 4. So x is 3 plus y is equal to 4. Subtract the 3, so we end up with y equals 1. So as you can see, we're going to have the same solution. Okay. So now that we have seen both methods, we're going to go ahead and try a couple of these, and then we can decide which method we want to use. Again, the method you use is going to be up to you, but either method will get you the correct answer. Okay. So it says solve the system of the equation using any method. So if we look at both of these, we can see that the first one, that's already solved for y. So the method I'm going to prefer to use here for myself is the substitution method because I already know what y is. Okay. So since y is equal to 2x plus 3, I'm going to go into my second equation, and wherever I see a y, I'm going to replace it with 2x plus 3. So here I have, I'm going to go to our equation. So let me go to the next step. So I have x plus, hold on, sorry. My phone is, okay, so here we go. So here for my y, I'm going to replace the 2x plus 3. So here's my equation, x plus 2y equals negative 4. I already know that y is 2x plus 3, so I replace that. And then we're going to simplify. So distribute the 2. So we get 2 times 2x is 4x. 2 times 3 is 6. And then we're going to gather our like terms. So x plus 4x, 5x. And then we'll subtract 6 on both sides. So we have negative 4 minus 6 is negative 10. Divide by 5 on both sides. So x is negative 2. Now that we know our x, then we can go ahead and find the y by back substituting. And we can choose any of the two equations. I went ahead and chose the first one. So I have 2 times x, but x is negative 2, plus 3 is equal to y. So we end up with negative 4 plus 3 is equal to y, and y is equal to negative 1. So our last step is to go ahead and write it as an ordered pair. So we end up with -2, -1. Any questions on that one? Okay, let's try a couple more. So here we have our equations. Again, we can see that y is equal to 2x minus 3. So that's already isolated. Okay, so I'm going to go ahead and use substitution. And so for my first equation, I have 3x minus 2y is equal to 7. But we already know what y is. So anywhere I see a y, I'm going to go ahead and substitute it with 2x minus 3. We're going to simplify. So distribute this -2. So we get -4x plus 6 equal to 7. And then if we combine our x's, we have 3x minus 4x is -x. So -x is equal to 1. Solve for x is equal to -1. Okay, back substitute. I'm going to choose that second equation. So x is -1. If I plug it in, then I get -2 minus 3 is equal to -5. So this would be my solution set. Again, substitution method, in my opinion, was a better method to use here since y is already isolated. But if you chose to use elimination, then that would still work as well. Okay, so let's look at this third example. So here, none of my variables are isolated. And so for me, I'm going to go ahead and use the elimination method. Okay, so we need to decide, do we want to get rid of the x's or do we want to get rid of the y's? We're going to go ahead and get rid of the x's. And so in order to get rid of the x's, the coefficients have to be the same with opposite signs, right? So if I want to get rid of the x's, um, I need to have the same coefficients. So 2, I can never make it a 5, and 5, I can never make it a 2. But if I multiply these together, then this can become a 10 and a 10. So we're going to go ahead and do that. So on my first equation, I'm going to multiply by a positive 5. 5 times 2x is 10x. 5 times -7y is -35y. And 5 times 3 is 15. You want to make sure you multiply everything for that equation. And then my second equation, I'm going to multiply by 2. So 2 times -5 is -10x. 2 times 3 is 6y. And 2 times 7 is 14. So now notice that one has a positive 10x and the other has a negative 10x. So they have the same coefficient with opposite signs, so they're opposites of each other. So I can proceed with the elimination method by adding them together. So I'm going to list them here. This is my first one and my second one. So 10x minus 10x is 0. -30y plus 6y is -29y. And 15 plus 14 is 29. Solve for y, so we end up with y is equal to -1. Okay, so now that we have our y, then we can go ahead and find our x by back substituting. So again, you can choose any equation. You can choose this equation or this one. You could even choose the new equations that we formed, right? So it looks like I went ahead and chose the first one. So I get 2x minus 7 times y. Y is -1 is equal to 3. So 2x plus 7 is equal to 3. And then subtract 7 on both sides. So we end up with 2x equals -4 divided by 2. X is equal to -2. So my solution is -2 and -1. Okay, so let's do, how about okay, we have another one. So after this one, we'll do a word problem. And then we'll get into the nonlinear systems. Okay, so what method would probably be easier to use here? And again, it's not so much about easier, but it's whatever you feel more comfortable with. So here I don't see anything that is already solved for x or solved for y. I could do that if I wanted to use substitution, but I'm gonna go ahead and use elimination since that's Mr. Carizales' choice there, right? And actually that was my choice as well. So let's go ahead and get started. So we need to eliminate a variable. I'm going to get rid of those x's. Okay. So here I have a -4 for x and I have a 2 for x. So I need them to be opposites of each other. So I know if I multiply the 2 by a 2, then I would have that 4. So I'm going to take that first equation and I'm going to multiply it by 2. Okay, so let's go ahead and do that. So 2 times 2x is 4x. 2 times -5y is -10y. And 2 times 6 is 12. So now I'm going to put them together. So I like to write them next to each other. So this is my new equation. And this is the second equation. And now you can see that one is a 4x and one is a -4x. So when I add them together, those x's will be 0. Oh, the y's are 0 also. And then 12 minus 1 is -11. So when this happens, 0 is definitely not equal to -11. Then we say that there is no solution, and we say it's inconsistent. So more importantly, what does it mean that it's no solution? So if you were to graph these, what would happen with the lines? So if you remember the graphs that I had earlier, if they don't intersect each other, then that's when there's no solution. So the lines never will cross each other. Okay. Now, what would happen if, let's say, the 0 was a -11? So what if it was -11? Let me write it here. Oops, hold on. I pressed the wrong button. What if we had -11 is equal to -11? Is that a true statement? Yes, right? Because -11 is equal to -11. So if you were to graph this, I'm just going to make this up right here, but maybe this first equation looks like this. And then if you graph the second equation, what would happen is it's going to be right on top of the other equation. It's the same line as Mr. Carizales said. So when you plot these variables or these solution points, you can have many, many solutions because they're all going to satisfy the equation. So what we would say here is that there's many solutions, and then you can write your answer like this. Okay, so x and y could be anything, right? Because all these points are going to be on the same line. And then you can pick one of the equations. So I'll pick the first one. And so that would be your solution set. Again, this is not for this example, but that's if you had -11 is equal to -11. And only because I don't remember if we have one of those in the presentation, but you might run into this situation. Okay, so how can we apply it? So let's look at this word problem. The given amount of annual interest is earned from a total of $9,000 invested in two funds paying simple interest, right? And solve a system of equations to find the amount invested at each given rate. So you have an annual interest of 380 that you earn from these two investments. One of the investments has a 2% interest rate and the other one has a 6% interest rate. So we want to find, so the question is find the amount invested at each of these rates. Okay, so the first thing is to recognize that you have two different funds. Excuse me, so you can call them A and you can call them B because there's two different accounts. And all we know about these two accounts is that they add up to 9,000 because we had $9,000 that we invested. And so A is going to have part of that 9,000 and B is going to have part of that 9,000. Okay, so just to make sure that we're identifying everything correctly, I'm going to say that my first account A was invested at 2% and my second account B was invested at 6%. So in order to solve this, we're going to need some equations. So one of the equations is that A plus B is going to be 9,000. Okay, so you have two accounts, they add up to 9,000. And then the second equation is that the interest rate for the first account is at 2%, and we're going to write that as a decimal. And then my second account was used at 6%. So in decimal, that's 0.06. And all we know is that together, these two funds earned $380 in interest rate. So now I have two equations, and I can solve for my variables. Now, if you like decimals, you can keep the decimals, but if you don't want to deal with the decimals, we can change them to a whole number. I can multiply by 100 all the way across. So 100 times 0.02 is 2. 100 times 0.06 is 6. And 100 times 380 is 38,000. So I'm going to write my two equations. A plus B is 9,000 and 2A plus 6B is 38,000. So now we choose a variable to eliminate and we can get rid of the A's. So in order to get rid of the A's, I need to have a negative 2A for my first equation. So that means I'm going to multiply negative 2 times the first equation. So that would be negative 2 times A is negative 2A. Negative 2 times B is negative 2B. 9,000 times negative 2 is negative 18,000. And then I can add it to my second equation, so the A's will become 0. 6B minus 2B is 4B, and 38,000 minus 18,000 is 20,000. So that means that for account B, I put $5,000 in that account. So how do we find out how much A has? We can back substitute. So if B is 5,000, subtract the 5,000. So that means that A was $4,000. So we put $4,000 at an interest rate of 2%, and we put $5,000 at an interest rate of 6%, and together it only earned $380. So you do not want to use simple interest to retire, right? Because that would be like not a good investment. So there's other types of investments that you can use for retirement purposes. For example, annuities, right? Okay, so I think the next thing is nonlinear systems. So I don't know if Mr. Carizales wants to take over and do nonlinear systems.
Of course.
All right.
All right, guys. So, nonlinear systems. Well, what are we talking about? Well, nonlinear systems, just like the name is, we're not going to be just dealing with a line. Um, and so if you see on our example here, the first one is a linear system because both of them are lines. But on our second one, we have a parabola with a line. But we could also have maybe two parabolas, or maybe a circle and a line, or a circle and a parabola. So that's what nonlinear system is when we not both of our graphs are going to be lines. So let's go ahead and look at an example. If we look at this, solve the system of equations by using any method. So they want us to solve any method. And if we notice on our first equation, we have an exponent of 2. So right off the bat, we know that we have a quadratic for that first one. And in our second one, oh, that's our general form of a line. So we have a quadratic with a line. So let's go ahead and solve this. Um, so let's go ahead and use the elimination method. So, and the reason why I'm using the elimination method is because we see, right? If I just add these two lines together, the y's are going to cancel out without me doing anything to it. So let's go ahead and do that. Let's add these two equations together. And when we do that, we have x squared minus y is equal to 0 plus 4x plus y equals to 0. and I have x squared plus 4x is equal to 0. Okay, so I'm going to go ahead and use my quadratic equation to solve for the x. Um, or we can factor it out, which is a lot better. Um, so if I factor out an x from x squared plus 4x equals 0, I'm left with x times x plus 4. Again, my zero property says that when I'm multiplying two values together, the only way that I can get 0 is if either x is equal to 0 or x plus 4 is equal to 0. So my two solutions I have are x is equal to 0 or x is equal to negative 4. Now to get my y, just like Ms. Chuka did before, we'll do back substitution, but now we're gonna have to test two values, right? So we'll start with um, the 0, let x equal to 0, and again, I can pick any of the two equations. It doesn't matter which one I pick. I just went with the easy one, which is the second one, 4x plus y equals to 0. So here I have 4 times 0 plus y equals 0. So 4 times 0 is 0. So y is equal to 0. So one of my solutions is 0, 0. Okay, let's go ahead and do for the negative 4 now. Again, I'm going to use the second equation again. I want to make my life easy. So 4 times negative 4 plus y is equal to 0. So a positive 4 with a negative 4 is going to give me a negative 16 plus y equals to 0. Add 16 on both sides, so y is equal to 16. So again, I have my solution set is 2 points. So my line crosses my parabola at 0, 0 and negative 4, 16. Yes. So easy stuff. Let's see. Let's go ahead and look at another example. Let's look at this. Now our first one we can tell is a line, and our second one is a quadratic or a parabola again. So since um, no variable has opposite sides, but it's still we have an easy way to do this. Let's go ahead and use the elimination method again. Okay, so what I need to do in order to eliminate one of the variables, I want to eliminate the y, but they need to be opposite signs. So let's go ahead and multiply a negative 1 to any of the equations. And again, I'm just multiplying the negative 1 to the first equation. So when I do that, um, I'm going to do negative 1 times x is going to give me a negative x. Negative 1 times a negative y, that's going to give me a positive y. And negative 1 times a negative 5 is a positive 5. And as Ms. Chuka said, it's very important that we multiply to the whole equation on both sides of the equation. Okay, it's a very common mistake that some of us may do. All right, so now let's go ahead and put them together and add them together. So we have x plus y equals negative 5, and we have x squared minus y equals negative 6. So when I add these, I have x plus the x squared. It's just x plus x squared, but my y's cancel. Plus y minus y is 0, and the minus 5 plus a negative 6 is a negative 11. Okay, so again, I have a quadratic equation, so I'm going to set it equal to 0. So we have x squared plus x plus 11 is equal to 0. And we try to see if we can factor it. So if we can factor it, let's go ahead and use our quadratic equation. Again, my values here for my quadratic equation that I'm using, a is 1, b is 1, my c is 11. Okay, so when I plug them in, um, I see that my square root is going to have a negative value in here. So yes, we've dealt with imaginary numbers already in this class, but for this class, we're going to see that this is an inconsistent system, that there's no solution for this. Okay, and there's no point of checking anymore because again, if one of them doesn't um, give us a true statement, then the other one won't either. Okay, all right. Whoa, let's look at this nonlinear system. On this one, what do we see here? Well, the second one, I know that's a parabola. It's a quadratic because I have the x has an x squared. But oh, the top one, both my x and y have a square. Oh, so I believe we are dealing with a circle on the first equation here. Okay, so right, Ms. Chuka's like happy that we recognize that, right? All right. So how should we solve this? Well, let's go ahead and try our elimination method again. Since that's the one we've been using, let's continue practicing since we feel comfortable with it. All right, so for me, what I'm going to do is I'm going to eliminate my x. So what I'm going to do is I'm going to multiply my first equation by a -3. That way I can cancel out my x squared. So let's go ahead and do that. I'm going to multiply a -3 times x squared. That's going to give me a -3x squared. A -3 times a positive y squared is going to give me a -3y squared. And a -3 times a positive 25 is going to give me a -75. So let's go ahead and put the equations together. -3x squared minus 3y squared is equal to -75. I'm going to add it to 3x squared minus 16y equals to 0. Okay, and again, it doesn't matter which variable you wanted to eliminate. I mean, we could have eliminated the y by multiplying by a 16, but that would have given me large numbers. So, but it doesn't matter. You can pick any variable to eliminate. You'll still get the right answer. So let's go ahead and do this. -3x squared plus 3x squared is going to be 0. Um, -3y squared minus 16y is going to give me a, a -3y squared minus 16y equals to -75 plus 0 is just a -75. Again, I am left with a quadratic, so I'm going to solve for 0. So when I do this, I can factor it or I can use my quadratic equation again. So we went ahead and tried our quadratic equation. So when we do this, we're going to end up with two values. So here I have y is equal to a -25 thirds and y equals to 3. So we have two points where our parabola is going to cross with our circle. Yes. So let's try the first point. Let's do the y equals 3. So everywhere I see y, I'm going to plug in the 3. And again, I just chose the first equation, my circle. Okay, so I have x squared plus 3 squared is equal to 25. So 3 squared is 9. So we have x squared plus 9 is equal to 25. Subtract 9 on both sides. We have x squared is equal to 16. Take the square root of both sides. So I have x is equal to plus or minus 4. So my solution, when y is equal to 3, I have positive 4 and 3 and negative 4 and 3. So this is the point where my parabola is crossing my circle. Now we need to try the other point. Um, the y equals -25 thirds. Again, everywhere I see y, I'm going to plug in the -25 thirds. So when I do that, -25 thirds squared is going to give me 625 divided by 9. So I'm going to subtract -625 over 9 to both sides. And if we see, we're going to get a negative answer. Um, and when we take the square root, it's going to give us imaginary. So again, there's no real solutions. So my only two true solutions are my first 2 points, the 4, 3 and -4, 3. Yes. So, um, and since we have a little bit of time, just so you can see what's going on, on the first one, it's a circle. I know that the center is at my origin. I have a radius of 5. So if I were to, um, sort of try to draw this circle. There we go. Um, with a radius of 5, and then we have our parabola. Okay, let's see here. Our points are 4, 3, and -4, 3. So we're looking at something like this, where our parabola is crossing our circle at 2 points. Yes. All right. So again, our solution set is 4, 3 and -4, 2. All right, let's look at one more. Uh-oh. So I can see that my second equation here is a linear equation, but my first one, I have an x and y value. Huh. Um, let's see, how can we deal with this one? Well, I can tell you this is also still a linear equation, but it just looks a little bit weird, okay? So um, let's go ahead and to solve this, let's use the substitution method, excuse me. Let's do something different. So what I'm going to do is I'm going to go ahead and get the xy minus 1 equals to 0. And I'm going to solve for x, okay? So if I do that, I have x is equal to 1 over y. And you see that this is still kind of, hopefully we see it's a linear equation, right? So let's go ahead and substitute it. So let's substitute to the second equation, which I'm going to substitute it to the 3x minus 6y plus 17 equals to 0. Here we go. All right, so then we have 3 times 1 over y minus 6y plus 17 equals to 0. Okay, so let's go ahead and multiply by y to get rid of that fraction because it's a little weird looking, right? So when we do that, we have a better equation, right? So we have 3 minus 6y squared plus 17y equals to 0. Uh-oh. So do we have a linear equation on that? Let's see. So let's go ahead and continue. So we see that we have a quadratic on here, okay? We thought it was a linear, but we have a quadratic. We have the y squared as with a exponent of 2. So we have a parabola that our x-axis is our major axis, right? So to solve this, again, um, we're going to use our quadratic equation. And when we do that, okay, we're going to left with two values. Y is equal to negative 1 over 6 and y is equal to 3. So, see, it was misleading. That first one is not linear, but a quadratic. All right, so let's go ahead and do back substitution to get our other points. We start with y equals negative 1 over 6. Plug it into the first equation. Okay, you can plug it into any of the two equations you pick. But I picked the first one. It's a lot easier. So we have x times negative 1 over 6 1 equals to 0. So we have negative x over 6 is equal to 1. Multiplied by a negative 6 on both sides. So we have x is equal to negative 6. Okay, so let's go ahead and do the y equals 3. So we have x times 3 minus 1 is equal to 0. So we have 3x. Move the negative 1 to the other side by adding 1 on both sides. So we have 3x equals 1. Divide by 3 on both sides. So we have x is equal to 1/3. So we have a solution set where we had a parabola on its side and a line, right? So where the line crosses our parabola is at negative 6 and negative 1/6 and at 1/3 and 3. Yes? All right. I think we went through those fairly quickly, Ms. Chuka. Does anybody have any questions? All right. Okay, Ms. Chuka's here stating me that's a rational function, right? Oh, yes. All right, Ms. Chuka's gonna go ahead and graph it for us. Oh, there we go. Oh, thank you, Ms. Chuka, for that. See, it helps a lot when we graph them. So hopefully you guys do this too. You know, for you to help. I mean, graphing won't help us get a solution exact points, but it can actually help us see if we have a solution or what we're dealing with, right? So it always helps to graph, right? Excellent, excellent. Ms. Chuka, would you like to add anything else?
Um, no, just that in the next section, it's gonna be similar, but now you instead of two equations, you're gonna have three equations. And eventually, these methods that we're learning right now, when you get to chapter 8, you're gonna learn additional methods using matrices, because eventually, whatever field you go into, if we have some computer science scientists in here or engineers and you run into systems of equations, you're going to have bigger systems, and you might have 10 systems or 30 systems or 1,000 systems. And so for those type of systems, then technology would be required, right? Like, so so yeah, these are pretty fun, and you'll keep seeing these methods for the next two chapters, for this chapter and the next chapter. And so we do have a few minutes, so if anybody has a question or needs clarification, we can go back on any of the slides.
Awesome. Thank you, Ms. Chuca. Thank you, Mr. Carizales. Again, if anybody has any questions, please let us know. So we do want to remind you all about the previously recorded sessions, which are available on our YouTube playlist. I just shared the link, and this session will be available on that playlist later today. Also linked is a short survey to help us improve our TVE sessions. Please take a few minutes to fill out that survey, and remember to send your student ID number to us before you log out. If you would like to download a copy of the presentations, you can go to the top right corner and click on the box with the arrow going down while the presentation's on the screen. That will allow you to download the PowerPoints. And I believe the little blue arrow on the screen, the download button should be right above that, okay? Before you all leave, I want to share the TVE sessions that we will have next week. Oops, sorry, give me just a second while I go ahead and share that flyer. Awesome, there we go. So join us again next week at 11 a.m. for a Happy Math Hour. Math 1314 will be covering basic matrix operations and using matrix operations, and Math 1324 will be covering sets. Our 1 p.m. session that day will be an EPCC Police Active Shooter training. Thank you all for coming in today. We hope you all have a lovely weekend. If you guys have any questions, feel free to use the chat box or your mic. We hope to see everyone again next week for Happy Math Hour.